Hi, so this is my presentation for the Coursera project on ML system design and analysis. The topic I have chosen is food consumption prediction and wastage reduction in office or company cafeterias. And we will look at five aspects of it: opportunity evaluation, crisp and business understanding, solution validation plan, ML system design, and potential risk in production. So introduce the problem. The problem is that there is huge quantity of food that is getting wasted in office cafeterias every day. And this is happening because in an office setting, the caterers do not have time to prepare food from scratch, because in an office setting, everyone is in a hurry. So what caterers do is they try to predict what is going to be the demand for the next day, and they try to bring in cooked or at least semi-cooked food. But if that doesn't get sold or that doesn't get eaten, then there's a lot of wastage which happens. So that's the problem that we are going to solve. So is there a problem? Yes, there's definitely a problem. We have observed that for offices with around 6,000 employees, there is daily wastage of around 150 kilograms of cooked or semi-cooked food every day. And if we take the cost of this cooked or semi-cooked food at $30 per kg, uh, because cooked and semi-cooked food is more expensive than raw food, because even manpower cost is factored into that, then the daily wastage turns out to be around $4,500, and that adds up to around $1.2 million for wastage in a year. So that's a lot of amount of money that is getting wastage every year for one organization of around 6,000 people. Can machine learning help solve it? Yes, machine learning can help solve it, because the patterns of your food consumption over the previous duration is correlated to the pattern of your food consumption in future. So the correlation is going to be there. If we are able to get the data for the previous food consumption and the factors that influence the food consumption, we should be able to predict what will be your food consumption in the future time. And does someone care? Of course people care, because there's $1.2 million of food which is getting wasted every year. And even if you can reduce the wastage by 70%, or even more than that is always good. But even if the reduction in wastage is around 70% and the solution itself costs around $300,000 to implement, still you could save around $550,000. So that's a lot of savings, even if the solution saves only 70% of the food wastage and not the complete 100% of food wastage. So that's a lot of money to save if we get the solution at 70% accuracy and save food wastage. So define the problem. Who's the target user? The food and beverage departments if it's a company owned cafeteria, or the caterers if the caterers are third party people in medium to large organizations, because to implement this solution, to realize the benefit, there has to be a minimum volume of employees in the organization. So we are looking at medium to large organizations. So what's the problem statement? Accurate prediction of food consumption across different food items. So the prediction has to be so much of salad, so much of soup, so much of pizza is going to be consumed the next day, and even in the pizza, this variety of pizza is going to be consumed. So that's the prediction what we are looking at. And why it matters? Because this will help reduce the immediate financial cost, because the financial cost is immediate. Whatever is the wastage is an immediate financial cost that everyone has to bear. Then there is a long-term ecological cost, because if food is getting grown and that is finally getting wasted, then the soil is getting damaged, the transportation cost of getting that food. So there's a long-term ecological cost associated with it. And finally, there's an intangible moral cost as well with wasting food, because so many people are not having sufficient food. And if we are wasting food, that too cooked and semi-cooked food, then that's a moral obligation on everyone. So how is it solved today? Because the caterers do not have understanding of machine learning models. So they do simple guessing what was the consumption in the previous day, and maybe that is going to be the next day. But that misses out on a lot of patterns which machine learning can help identify. Gaps in current state, of course there are gaps. So we saw around $1.2 million of food getting wastage for a mid-sized organization every year. So that's a lot of wastage. So success criteria, the expected business impact is the expected annual saving should be around $250,000 to even more. We looked that it could even be $550,000, but it should at least be $250,000, because this involves collecting data. This involves that the employees will have to provide access to their data. What is their schedule? What are their religious preferences? What are their food eating patterns? So if savings are going to be less than $250,000 for an organization, then it may not be good to go for it. But so that's the saving we are looking at. The constraint, of course, will be reluctance from the employees to share their data, even though we don't expect it to be a major issue, because finally it's not confidential data. It's about what you're eating every day and what was your daily schedule like, so which influence your eating patterns, etc. So what are the metrics? So outcome is money saved by accurate prediction of the food consumption in the office, and output is % reduction in kilograms of the wasted food as compared to the average. And success criteria, as we said, outcome should be more than $250,000 of money saved for a mid-sized organization every year. And output could be more than 70% of food wastage reduced for an organization. And what are the factors which are going to be relevant? Domain expertise is not really required here. The factors are going to be which employees are expected to be present the next day, because finally only those can consume food in the office cafeteria who are physically present in the office. So prediction of who's going to be in office the next day, that's one important factor. Then for the employees who are going to be present the next day, what are their food consumption patterns, and based on which we can predict what they are going to eat the next day. And any other religious factors or special festivals and events which they observe, and on the occurrence of that day or event, their food patterns become different from what was the norm. So these are the factors which will need to be considered. So briefly describe the solution and how it will use ML. So what we are going to do is we are going to predict the food consumption of each employee the next day, and then sum it up to arrive at the final prediction, the aggregated prediction of food consumption the next day in office, which the caterers can then leverage to plan their food bringing, cooking activities. And the first thing the system will need is access to the leave management system of the office, because whoever is on leave is not going to be in office. So we can exclude them for the prediction for the next day when they are going to be on leave. And then for the employees who are going to be present, we need to look at their day-wise food consumption patterns, because there could be specifics like Monday, Tuesday, Wednesday. This person has a schedule that on Monday he prefers this, Tuesday he prefers that. So their day-wise food consumption, even season-wise food consumption patterns, because it could be the case that in summers on Fridays an employee likes to go to the gym at around 5 p.m. and so he eats eggs in lunch on Fridays in summer months. Similarly, there could be a pattern that an employee who observes a certain religious event on, say, Tuesdays eats salad only on Tuesday. So these patterns could give us an idea of what each employee eats on specific days or seasons, or combination of seasons and days. Then it could also be that the office work schedule affects your eating patterns, because it could be observed that if I have many meetings on a given day, then I might eat something that is substantial but still not heavy. So something like a fruit smoothie or something like dry fruit smoothie could be the preference for a day when the office schedule is full, and when the office schedule is lenient, then I may eat more because I can afford to relax, etc. And then we expect employees to flag any anomalous days, because they could point out that on this day, say 12th of March, it has special significance. On this day I don't eat anything, or 14th of July has some significance. On this day I eat a lot of food which I otherwise would not eat on any other day. So any such anomalous days we expect the employees to flag to us, so that we can accommodate that in the modeling and pattern. How we will go about implementing this? We will shortlist a small subset of employees who are most willing to participate in the pilot of it. Then we will collect relevant data from them over a course of 1 month. Then we will build a simple ML model, not so complicated, because limited set of employees, limited set of features, and see if that model is able to predict or be accurate up to a threshold of accuracy, which is slightly subjective. What is the threshold? And then we can decide if this project is worth going forward with or not. If that result is not encouraging, then we may repeat the pilot with another set of employees, and in a way try to get a preliminary idea of whether we should go ahead with the full-fledged modeling and implementation process or not. Then the ML system design. So once we decide to go ahead, what are the 3 important ML system design considerations? First is whether it will be cloud or edge based. So with this, it will certainly be cloud-based because there's huge computational requirements because we are dealing with data for each employee, and there could be 5,000 to 10,000 employees in the company office. For each employee, there are many features to be considered. So there's huge amount of data which needs to be processed both for training and for inferencing. And that level of processing can only happen on the cloud. So that's one reason for being on cloud. Secondly, it's not a real-time system because finally, at the end of each day, so the day ends at 5 p.m. or 6 p.m., it could even be by 7 p.m. that I need to provide the prediction for the aggregated food consumption for the next day. So I have like a lot of leeway in terms of time, even 1 hour of time is there. So it's not a real-time system, latency is not an issue. And so that's why cloud is another reason why cloud will be a preferred deployment option. Thirdly, since we are dealing with an urban office environment, so connectivity is not going to be an issue in an urban office environment. It may go down for 20 seconds, it may go down for 5 minutes at the most, but it's not going to be down for more than that in an urban office environment. So all these three reasons that computational requirements will be huge, latency is tolerated, and connectivity is not an issue. So quite obviously it's going to be a cloud deployment. Then whether offline training or online training. So we saw that offline training means weekly retraining and online training means training every minute. But both are kind of suboptimal in this use case because weekly training will be too late. We don't need to retrain every minute also. So what I suggest is we will go for a hybrid approach of online and offline training where we will train the system every few minutes, not every minute, not at the end of the week, but we will train it every few minutes, or we could train it at an hour's duration or even at the end of the day. So there's a lot of flexibility on when the retraining may happen, and that will emerge when the system goes under deployment and we realize what is the retraining frequency which is actually required. So this aspect of retraining could be decided when the system hits the production. And based on what is the data drift, the concept drift which is happening, we could decide what is the retraining frequency. And that's why I'm suggesting a hybrid approach. We will not categorize it as offline or online. We will keep the option open. Finally, the prediction, whether it's batch prediction or online prediction. So it is going to be a batch prediction. Even though we are trying to predict what each employee is going to eat the next day, finally we provide an aggregated prediction only, that all employees put together, this is going to be the pizza consumption, this is going to be the salad consumption, this is going to be the soup consumption. In soup consumption, this soup is going to be consumed in so much amount. In pizzas, this pizza will be consumed in so much amount. In salad, these salads will be consumed in so much amount. It's an aggregated prediction, not specific to each employee. Even though we use employee specific data, finally we give an aggregated prediction. So that's why we will go with a batch prediction approach. So this is how the model will going to be: cloud-based, a hybrid of training approach and batch predictions. What is going to be the potential risk in production? So of course there are going to be risks. First is the training and serving skew, because what is going to be the case is historical data on what each employee consumed over different days, over different seasons, over different months, years is going to be limited unless the organization already has digital cafeteria and they are already keeping track of what all each employee is eating, even though they have not implemented the ML model. So if that is not the case, that historical data is not going to be in the right format. And what we are going to do is create synthetic data. So we will speak to the employees, what are their preferences, what they eat on different days, how their schedule in office affects their eating patterns, and we will try to create synthetic data to make up for lack of actual data in the right format. But when we use this synthetic data to train the model, when it's deployed in the production system, we will observe a training and serving skew because we use the synthetic data for training. And now we are dealing with actual data in the production environment. So training serving skew is going to be there. How we can remediate it? If we really observe that the training serving skew is being observed, then next 6 months data we could use for training purpose. And we could eliminate the synthetic data which we earlier used because that's creating problems. And the next 6 months data we could use for retraining the system. So this will delay the actual production deployment, but that's what we will have to do if we observe that the training serving skew is going to be there. Then data drift. Yes, data drift is likely to happen because one reason is what employees are going to eat in the office cafeteria could be affected by their after office schedule as well. Because if after office I'm going to say a buffet with friends, then I may eat less on that day because finally I'm anyway going to a buffet in the evening with my friends. Or if after office there's an event in the family with friends where I'm anyway going to be eating a lot of food, then again I will eat less. So in this way, after office schedule is also going to affect my eating patterns in the office, and that could introduce data drift. And to remediate that, we may have to request the employees to provide data on their after office schedule as well if they want the predictions to be more accurate. Because finally, there are benefits for everyone if the predictions are accurate. We saw the financial cost, which is immediate, the ecological cost, which is long term, and the moral cost, which is intangible, but yet something we need to be worried about. So employees may agree to provide their after office schedule data as well. Then concept drift could also happen because we have uncovered the relations that on these days, seasons, months, office schedule, this is the food pattern that the person follows. But if a person is diagnosed with a significant disease in the course of events, then because of that disease and the recommendation of the doctor, his eating patterns will change, irrespective of what pattern he was following previously. Now, because of the disease being discovered, he will follow a different pattern based on doctor's recommendation. So the correlation between the features and the output is going to change because the doctor has come in the way and has created a different, what you can say, a different ML model of himself, that this is what you have to eat irrespective of what you have been eating before. So what we will do here is we will try to see what is the impact of this concept drift. To what extent and to how many employees are health issues making their food patterns change significantly. If the change is not significant, we could ignore this. But if the change is significant, then we may have to try and include the employees' health related data as well to make the model more accurate. But this remains the final difficult step because employees may be reluctant to share their health data just to make the model more accurate, even though there are benefits to making the model more accurate. They will be happy to share their daily schedule, maybe after office schedule as well, their religious preferences, but there could be reluctance in sharing their medical data just to make the model more accurate, despite the benefits that come with reducing the food wastage. So that could be something which needs to be decided on real time. What is the impact of health issues on prediction accuracy, and how to remediate that if health issues are making a significant concept drift in our model and making it less accurate. So that was the overall presentation from me. Thank you, and let me know your feedback. Thank you.